The Avro RJ cockpit is centered around 4 Electronic Flight Instrument System (EFIS) screens, 2 for each pilot. Each pilot has an upper primary flight display (PFD) and below a navigation display (ND). Each pair of EFIS screens is driven by its own dedicated symbol generator (SG) and has its own cooling fan. The screens provide information from the following aircraft systems: both IRSs, both GNLUs or GNSX, both ILS, VOR, DME, and ADF receivers, both ADCs, the weather radar, and both radio altimeters. Should a symbol generator fail, the remaining can serve all 4 EFIS screens. Each pair of EFIS screens has its own master switch through which power is supplied. Control of the EFIS screens is via a dimming panel (DP) and an EFIS control panel (ECP) on both sides of the flight deck. Moreover, there is an EFIS transfer switch on the captain's side. Indication and operation of the captain's and first officer's EFIS are basically the same. The description in this model applies to the captain's EFIS. Where differences exist, these are outlined. Each EFIS screen has an inclinometer, slip indicator, mounted at the bottom of the instrument. The dimming panels, DPs, are located on the left of the PFDs and contain the following controls: bright PFD, bright ND, bright WX, decision height, DH set control, and test button. Bright PFD. Rotating the BRT PFD knob controls the brightness of the PFD from a minimum to maximum. Compact PFD. After failure of the PFD, information of both PFD and ND can be combined. On the lower display by rotating the BRT PFD knob counterclockwise via detent to the compact position. Bright ND. Rotating the BRT ND knob controls the brightness of the ND from a minimum to maximum. Compact ND. After a failure of the ND, information of both PFD and ND can be combined. On the upper display by rotating the BRT ND knob counterclockwise via detent to the compact position. WX control. Weather display brightness is controlled by a black knob mounted on the BRT ND knob at the DPs. Rotating this knob from the WX off position through a detent clockwise displays weather radar information on the ND. DH control. Decision height, DH, is set from the DP by rotation of the DH knob and is displayed blue in the lower right corner of the respective PFD. It can be set from 0 to 500 feet, which is the clockwise detent. The DH readout is removed when rotating the knob to its counterclockwise detent. DH can be set at an altitude but is removed from 2,500 feet radio altitude after 5 seconds following selection. Test button. The test button is pressed to test the Efis and on-side radio altimeter during the cockpit check originating. The procedure will be covered later in this module. We are now looking at the information provided on the primary flight display PFD. Attitude data is supplied by the IRS and indicated as white line from the horizon, the earth below as brown area, and the sky above the horizon as blue area. The aircraft symbol is situated at the center of the display and is either a yellow delta symbol or a gray symbol, depending on the operator's choice of flight director. In this module, we will refer to the delta symbol. Roll reference is provided by a hollow triangle against markings for 10, 20, 30, and 45 degrees on the upper periphery of the attitude display. Pitch reference is provided by a scale marked every 2.5 degrees and numbered every 10 degrees. If the aircraft pitches beyond 30 degrees, either up or down, red chevrons appear to guide the aircraft back to normal attitudes. Below 2,000 feet radio altitude, the pitch limit indication, PLI, is posted as white eyebrows. The PLI represents the pitch attitude at which stick shake would occur in the present flight conditions. This is a very useful indication during wind shear when it might be necessary to pull up to a maximum safe pitch attitude. Radio altitude is indicated at the bottom of the PFD in green when the system is operational and the aircraft is below 2,500 feet radio altitude. Set decision height is displayed in blue in the lower right corner. Here, 200 feet radio altitude, once radio altitude is displayed below 2,500 feet. Above 2,500 feet radio altitude, both the radio altitude and decision height displays are blanked. The decision height value will start to flash 50 feet above until reaching decision height. Below decision height, the value will be replaced by bigger yellow DH until 10 feet when it is removed completely. The radio altitude will turn yellow when below decision height until 10 feet when it returns green. The airspeed tape is on the left of the PFD and is scaled in 10 knots divisions. The speed, which is normally green, is shown as an enlarged number halfway up the scale. With changing airspeed, the tape moves up or down and the displayed speed changes accordingly in steps of 1 knot. Mach number is shown in green below the tape when it is greater than Mach 0.40. Below 30 knots, white dashes are shown. A magenta speed trend vector line is displayed at the right side of the speed tape. It indicates the predicted airspeed in 10 seconds at present rate of d or acceleration. In this example, 164 knots. A cyan triangle on the right side of the speed tape indicates the selected speed, VSEL. The numerical readout of that speed is repeated next to the speed tape. The pilot can change VSEL at the MCP. Above 100 feet AGL, there are 2 types of speeds displayed at the right edge of the speed tape. The first one consists of a red and black tape extending from 30 knots to VSS, stick shake speed, which equals 1.05 times stall speed. When flying below VSS, the airspeed readout turns red. When only the trend vector ends in this band, the readout is yellow. The second band is yellow and extends from VSS to Vmin, which equals 1.25 times stall speed. When flying in this band, the airspeed readout turns yellow. Maximum speeds for extended flaps, VFE, or for extended gear, VGE, are displayed from the respective speed up to VMO or MMO as a yellow band. Here we have the maximum speed for flight with flaps extended to 18 displayed, 215 knots. If the airspeed enters the yellow band, the readout turns yellow. If the gear is raised or flaps retracted, the yellow band disappears and the speed turns green. Maximum operating speeds, or Mach number, VMO or MMO, are displayed as black and red tape extending from these speeds upwards. When the